This is Miss Downey, and we are doing day 2 of complex numbers. Day 1, yesterday, we learned to identify, graph, and perform operations with complex numbers. Today, we're going to find complex number solutions of quadratic equations. So I'm starting with review of yesterday's division of complex numbers. So if you'll take 4 minutes and do those now. Okay, so if you'll bring your attention back to our work, let's solve these and check your work as I work them out. On the first one, we've got to clear the denominator because there is an I in the denominator. We can't have that. So we had a rule that said if we multiply the complex conjugate, we can simplify that to a squared plus b squared. So we're going to multiply by 3 minus 4i over 3 minus 4i, because all we're doing is multiplying by 1. But we're making 1 fit our needs. So here we're going to have 5 minus 2i times 3 minus 4i over, and now we're going to do a squared plus b squared. So 3 squared plus 4 squared. That's going to be 9. This is going to be 16. So these added together will be 25. So we've simplified the denominator to 25. Now let's work on the top. To FOIL, we've got 5 times 3, 15. Outside, negative 20i. Inside, negative 6i. And last, positive 8i squared. Okay, now we're going to clean up our like terms. So negative 20i minus 6i is a negative 26i. And then I squared is negative 1. 8 times negative 1 is negative 8. So now we have 15 minus 26i minus 8 over 25. 15 minus 8 is 7 minus 26i over 25, and then we're going to split that answer up into 2 terms. So it's 7 25ths minus 26 25ths I, and that's our answer for A. For B, we're going to clear the denominator again by multiplying by the negative 6i. Same manner. So we've got negative 6i times 4 minus I over 6i times negative 6i is negative 36i squared. I squared is negative 1. And then negative 1 times negative 36 is a positive 36. So now we've got our denominator of 36. Let's work on the top. So negative 6i times 4 is negative 24i. And negative 6i times negative I is a positive 6i squared. Now, we can see that we can take a 6 out of every term here. So let's simplify in 1, 6, and 4. So we have negative 4i plus 1, and I squared is negative 1. So times negative 1 all over 6. Okay, so this 1 times negative 1 goes to negative 1. So we have negative 4i minus 1 over 6. So let's split those up. Negative 4i over 6 minus 1 over 6. And we need to put our real number first. Negative 1 over 6 minus, and 4 6 simplifies to 2/3. 2/3 I. And that is our answer. The last problem, we have 8 minus 7i over 8 plus 7i. So we're going to multiply that by the denominators conjugate. So 8 minus 7i times so now we can say our bottom term is going to be 8 squared plus 7 squared, which is 64 plus 49, which comes out to 113. So we've got our denominator covered. Our denominator is 113. Now let's work on the top. So we have 8 times 8, which is 64. Now outside, 8 times negative 7i is negative 56i. Inside, again, negative 56i. And last is negative 7i times negative 7i, which is a positive 49i squared. Writing that sideways. And we know that our I squared is negative 1. So 49 times negative 1, we end up with a negative 49. Alright, now continuing, we're going to have 64 minus 49, which is 15. And then 56i, negative 56i twice is negative 112i over 113. So now let's split it up. 15 over 113 minus 112 over 113i. And that's our answer. So those took some time. They're number crunching. You'll have one of those on the test. So I wanted to make sure you've got those because those are truly easy. And a wonderful practice to build all your skills in algebra 2. So moving on with our lesson and continuing with problem 6. Our essential understanding for this problem is that sometimes you'll solve a problem and you'll find out that every quadratic has a complex number solution. And sometimes they're just real numbers. So far we've been working with just real numbers, right? But some quadratic equations have pure imaginary solutions. So let's find, how do we do a pure imaginary solution? So it says, what are the solutions of 2x squared plus 32 equals 0? Well, got it. I thought I had it. Well, our first step is to try to isolate x, correct? So we're going to subtract 32 from each side. Excuse me. Our next step is now to divide everything by 2. Right? We divided both sides by 2. Now we end up with x squared equal negative 16. So now we're going to take the square root of each side. And you get x equal positive negative radical negative 16. But we're still not finished, right? Because that's going to come out as an I. So we'll have I radical 16, which is 4. So let me show you this step here. You have x equal positive negative radical negative 16. Well, this comes out as an I. And you're left with x equal positive negative I radical 16. Well, radical 16 is 4. So 4 times I is 4i. So you get x equal positive negative 4i. So it's a positive 4i and a negative 4i. So on that imaginary axis, it's there and there, 4i and negative 4i. So now I would like for you to take 2 minutes and work these 2 problems. On your whiteboards and go. Okay, so bring your attention back up here and let's check these together. So we're just trying to isolate our x. So we want to get rid of 20, so subtract 20 from each side, and you get negative 20 equals 5x squared. Now divide both sides by 5, and you get that x squared is equal to negative 4. Now we want to clear the square, so take the square root of each side, and this gives us x equal positive negative radical negative 4. So now that comes out of here as an I. So we have x equals positive negative I radical 4. And the radical 4 is 2. Square root of 4 is 2. And 2 times I is 2I. So now we have x equal positive negative 2I. So again, graphing your complex number, it's going to be a positive 2I and a negative 2I. They didn't ask us to graph it, but I wanted to remind you how to graph these things. And it's not moving on the real axis because there's no real part to this complex number. It's pure imaginary. Sounds whimsical, doesn't it? Okay, let's look at the next one. So now we have to subtract 15 from both sides. And we have x squared equals negative 15. We'll take the square root of each side, and we get x equals positive negative, and this comes out as an I radical 15. And that's as simplified as we can get it, and that's your answer. Okay. If this was not in terms of a radical, you would have to get your calculator, take the square root of 15. Right, there it is, 3.8792, and add that. Look for that. 3.87i, positive and negative. 3.87i. Okay, our last problem is what are the solutions of 2x squared minus 3x plus 5? So in my head, I'm already trying to do a magic x. I'm trying to clear, can't clear the 2. So let's do 2 times 5, which is 10. What 2 factors of 10 add up to be negative 3? None. So this is unfactorable. So in that case, that's when we use the quadratic formula. So what is it? We've got x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Now our a is 2, our b is negative 3, and our c is a positive 5. So substitute. So x equal negative b, negative 3, plus or minus the square root of b squared, negative 3 squared, minus 4 times a, which is 2, times c, which is 5, all over 2a, which is 2. Now it's just simplifying. So negative times negative goes positive, and then negative 3 squared is a positive 9. Negative 4 times 2 is negative 8, times 5 is negative 40. So now we have 9 minus 40, and that's a negative 31. 2 times 2 is 4. Okay, so now let's put it back together. So we're going to have x equals 3 plus or minus radical negative 31 over 4. And this needs to go out, so make it an I. So our final answer is x equal 3 over 4 plus or minus I radical 31 over 4. And that's our answer. Okay, so there it is. There's your answer. And that concludes not just this lesson, but our our chapter. And this will be the last thing we work on before we get our study guide. And so I need you to finish your 4-8. So I want you to do the back side, because yesterday we did the front side. And I want you to work all the problems. Okay? And that concludes our lesson and chapter. Thank you for watching.